Hi, this is Michelle Cullen in Prince William Sound College, located in beautiful Valdez, Alaska. Today I'm going to cover the topic that you've always wanted to know. Just how bright is that star? Remembered star bright, star light, first star I see tonight. Well, we know that stars are bright, and just how bright are they? Some stars in the night sky shine brightly, others are dim. The ancient Greek astronomers classified the brightest stars as those of first order magnitude. Those stars really stand out in the night sky and may be the only ones you can see if the moon is out or you live where there's some light pollution. The ancient Greeks classified the stars going in a scale from 1 to 6. Each number higher is a little bit dimmer. So we have first order magnitude stars, second, third. And the brightest stars that you could see with your eyes, if you had good eyesight on a dark night, would be magnitude 6 stars. So this scale is important. If you're in a basic astronomy class, you really should know how we classify the magnitude of stars. It's just like on your star chart, the brighter the stars, the larger the circles. So those really big circles are magnitude 1. The problem with the Greeks scale, well, there's several problems. It's counterintuitive, and we end up with objects in the sky that are brighter than a first order. We have stars that are order of magnitude 0, and we also have ones that are negative, like Sirius, the brightest star in the sky, negative 1.5. The planets, when they come up, especially Venus and Jupiter, are also negative apparent magnitudes. Stars can actually be used as an eye test. The asterism Pleiades, known as the Seven Sisters, is an example of this. Now, people with average eyesight can only count 5 of the Seven Sisters on a dark night. But if you have really good eyes, you will be able to count all 7 of the sisters. And if this is the case, you might be considered worthy to be a good hunter. How do you find Pleiades? Well, find the constellation Orion in the night sky, look at its belt, and then follow this arrow from its belt up past Taurus and the bright star of Aldebaran up into the asterism of Pleiades. And look for it next time you're out on a winter starry night. Well, let's move beyond this counterintuitive scale to something that's better. The true property of a star, its luminosity. Astronomers classify stars not by how we see them on Earth, but from what their output of energy is. We want to know the true brightness of a star. We can look at the amount of light energy or unit energy it's being put out per second. This measurement of stars' luminosity is in watts, just like for your light bulbs. So if you have 2 light bulbs that are the same number of watts, one is close, one is far away, it follows a rule called the inverse square law. And we're going to look at that in a second here. So we look at this sphere here. The apparent brightness of a star really depends on its luminosity, its intrinsic luminosity, the number of watts it's putting out, and how far away it is from the observer. So you can see that as you double the distance of energy, the amount of energy per square area is 1 over 2 squared. 2 times 2 is 1/4. But when you go 3 times away, the energy gets spread out over a area 1 over 3 squared, which is 1/9 the energy. So you can see that the amount of light drops off quite quickly as you move farther and farther away. It's not just a linear relationship. Well, this is useful to be able to calculate the true luminosity of a star. You can use this formula if you know its apparent magnitude and how far away it is. So when we know the true luminosity of a star, we can just put everything and rank them in terms of a standard candle. And since we have our special sun as the one that's near and dear to us, we will compare all of the stars in the universe to our luminosity of our sun. And it makes sense because it is an average type of a star. So we'll say our star has one luminosity and other stars might have more or less. For example, the star Sirius, which is the brightest star and is 8 light years away, has a luminosity that's 25 solar luminosities. The red supergiant Betelgeuse actually has a luminosity of 100,000 times our sun's luminosity. But it's far away, so it doesn't appear that blindingly bright. Well, today I've covered a little bit about how bright stars are, what our traditional ancient apparent magnitude scale is, and how we use luminosity to compare stars. I hope this clarifies, lights up your concept of luminosity.